Interesting facts about space debris, a growing concern in the realm of space exploration and satellite operations. 1. Definition of space debris. Space debris, also known as space junk, refers to non-functional, human-made objects in orbit around Earth. This includes defunct satellites, spent rocket stages, fragments from collisions, and other discarded materials. 2. Vast numbers. As of 2024, there are more than 36,000 pieces of space debris larger than 10 centimeters being tracked by organizations like the U.S. Space Surveillance Network. Additionally, millions of smaller pieces, from paint flecks to tiny fragments, are too small to track but still pose risks. 3. High-speed hazard. Space debris travels at extremely high speeds, up to 28,000 kilometers per hour, 17,500 miles per hour. At these speeds, even small fragments can cause significant damage to operational satellites, spacecraft, or the International Space Station, ISS. 4. Kessler Syndrome. The Kessler Syndrome, proposed by NASA scientist Donald J. Kessler in 1978, describes a scenario where the density of objects in low Earth orbit, LEO, is high enough that collisions between objects could trigger a cascade of further collisions, exponentially increasing the amount of debris. 5. Notable collisions. One of the most significant space debris events occurred in 2009 when an inactive Russian satellite, Cosmos 2251, collided with an active U.S. satellite, Iridium 33. The collision generated thousands of pieces of debris, many of which remain in orbit. 6. Anti-satellite tests. Deliberate destruction of satellites, such as during anti-satellite, ASAT, missile tests conducted by countries like the US, Russia, China, and India, has contributed to the space debris problem by creating thousands of new fragments. 7. Space debris monitoring agencies like the European Space Agency, ESA, and the U.S. Department of Defense track space debris to predict potential collisions. The data is used to inform satellite operators when evasive maneuvers are needed to avoid debris. 8. Debris mitigation guidelines. International guidelines and best practices have been developed to minimize the creation of new space debris. These include measures like deorbiting defunct satellites and spent rocket stages at the end of their operational lives. 9. Space debris removal efforts. Several initiatives are being developed to remove space debris, including concepts like nets, harpoons, robotic arms, and even lasers to nudge debris into a lower orbit where it can burn up in Earth's atmosphere. 10. Risk to human spaceflight. Space debris poses a serious risk to human spaceflight. The ISS has had to perform numerous debris avoidance maneuvers to dodge incoming debris, and its protective shielding is designed to withstand impacts from smaller debris. 11. Geostationary orbit concerns. Geostationary orbit, GEO, where many communication satellites reside, is particularly sensitive to debris accumulation. Objects in GEO are much harder to deorbit, and the region is becoming increasingly crowded. 12. Long lifespan in orbit. Space debris can remain in orbit for decades or even centuries, depending on its altitude. Objects in low Earth orbit, LEO, may re-enter the atmosphere and burn up within a few years, while those in higher orbits can persist for much longer. 13. Legal and regulatory challenges. The management of space debris involves complex legal and regulatory challenges, as space is a global commons. International cooperation is crucial to addressing the issue, but there is still no binding international treaty specifically governing space debris. These facts underscore the growing challenge posed by space debris, highlighting the importance of international cooperation and innovative solutions to ensure the sustainability of space activities for future generations. Thank you for watching. Like, comment, share and subscribe for more.